In the last lecture, we discussed a classification algorithm that is k nearest neighbors. And today we will be discussing about the performance evaluation matrices. Performance evaluation of a classification model is crucial for understanding how well the model predicts the correct labels for new unseen data. It helps assess both the accuracy and reliability of the model, providing the insights into areas where the model may be making errors. A range of matrices can be used to evaluate the classification model, each with offering different perspective of performance. We will So let's start with the confusion matrix. A confusion matrix is a key tool used to visualize the performance of a classification model by showing the relationship between the true labels and the predicted labels. So it's a 2 by 2 grid or a table that has actual values on one axis and the predicted values on another axis. So we can see there are four cells in this table or a grid. True positive, true negative, false positive, and false negative. So let's understand each of them. So true positives are those instances that were actually true and the model also predicted them as true. True positives are those instances that are actually true and the model also predicted them as true. Similarly, true negative. They are those instances that were actually false and the model also predicted them as false. So true positives and true negatives are the actually true records or correctly predicted records. Now let's talk about the false positive and false negative. These are actually the errors that are made by our model. So false positives are those records that were actually negative, but the model has falsely classified them as positive. So they are called false positives. What about false negatives? False negatives are those records that were actually positive, but the model has wrongly classified them as negatives. So they are called false negatives. uh, for example, you are going to classify if a person is has a brain tumor or not. So we have an MRI image and we want to predict if the an MRI contains a brain tumor or not. So what is true positive? True positive means the MRI contained a tumor and the model also predicted that MRI as tumor. What about false? What about true negative? True negative means a patient had no tumor, and the model also predicted it as healthy. So that's true negative. So these are the true results: true positive and true negative. But if a person has no tumor and the model classify is as a tumor, so that's a false positive. So there was no disease, there was no tumor in the MRI, but the model predicted that as a positive class, as a tumor class. Similarly, for negative, the model actually has the MRI actually has the tumor, but the model predicted it as healthy. So it was actually the positive class, but the model predicted as a negative class. So these are two errors, and we also call one and type 2 errors. Uh, Here are some examples of these true positives, true negatives. So false positives are called type 1 error, and false negatives are called type 2 error. So here is another example similar to what we discussed. For example, uh, we have two labels. One is actual label and other is predicted label. So actually, the first label is actual sick. So actually, the particular patient was sick or not, and what the model predicted. So if the actual patient was sick and the model also predicted as sick, then it is true positive. The outcome is true positive. If the patient was not sick and the model also predicted it as not sick, then it is true negative. So there are no errors. What was the actual value? The same was predicted by the model. Same case, same for the goes for the third, same for the fourth, same for the fifth. Now let's see where is the error. For example, come to the ID number 7, And here the patient was actually sick, but the model predicted as not sick. So that was actually sick, and the model predicted as not sick. So it should be false negative. There should be some mistake in the presentation. I will correct it later. So that should be a false negative. Similarly, a person was actually not sick, and the model predicted it as sick. It should be uh, false positive. So now I have updated the slides, and now you can see that if it was actually positive and model classified as negative, so it is false negative. Similarly, if it was negative and model classified as positive, so it is falsely classified as positive, so it is false positive. Okay, so using this data, we can create a confusion matrix. You just have to draw a 2 by 2 grid. You can place actual here and predicted here. So we have two classes, positive 1 and 0. So we will indicate positive with 1 and negative with 0. So we have 1 0 here and 1 0 here. Now this is the first box of true positive. So we will count how many true positive we have. So we have the first instance and the fourth instance. So we have two true positives. Now we will count the true negatives. So we have second, third, fifth, sixth, and ninth instance. So here are five true negatives. So there are actually seven true records. So now we will look for the errors. So we have one false positive and we have two false negatives. So here we have our confusion matrix, and we have also taken the total of the rows and columns. So total positive that were predicted were 3, total negatives that were predicted by the model were 7, and actually there were 4 positives and 4 negatives. So 6 negatives. Here is another example. For example, we have given the y, the actual y, the actual label, and the predicted label is suppose it is from some logistic regression model and is predicting the probabilities, not actually value. So we have a threshold of 0. 0.6, and using that threshold, we are actually classifying the predicted value into either of the two classes, 0 or 1. So if the value is 0. 0.6 or above, we will classify it as 1, and if it is less than 0. 0.6, then we will classify it as 0 class. So you can see that the first instance has the predicted value of 0. 0.5, so we have classified it as 0. The next has greater value than 0. 0.6, we have classified as 1. Then the next is also 1, and the next is also 1. The last three values have the value less than 0. 0.6, so we have classified them as 0 class. So let's see how many true positives and true negatives we have. So first label has been correctly classified, so it is true negative. The second one is true positive. Third one has the error, so it was actually negative and it is falsely classified as positive, so it should be false positive. The next one is 0 1 1, that is true positive. The next is 1 0. The actual value was positive. The model falsely classified as negative, so it is false negative. Then we have true class, a false class, and a false class, that is true negative. Then we have a true class and a false class, that is false negative. And we can create a 2 by 2 grid or a confusion matrix from this data as well. You can see that we have two true positives, true negative, one false positive, and three false negatives. Now we'll discuss the evaluation matrices that can be calculated using the confusion matrix. So the first one is the straightforward and the most simplest evaluation metric, that is accuracy. So what is accuracy? It is actually the true results divided by the total number of results. So the simple formula for to calculate the accuracy is the true results, uh, that the true positives plus the true negatives. So if you divide this by total number of records or the total number of positives plus negatives, it's the same thing. So you will get the accuracy. For example, here we have total 10 number of instances. Total true positives classes are 3 and total negative classes were 7. So we have total 10 records, and out of which the truly or correctly predicted records are 5 true negatives plus 2 true positives. So we have 7. Out of 7, out of 10, 7 records were correctly predicted, which means we have an accuracy of 70%. So 2 plus 5 divided by 10, we will get 0.7, and then we will multiply it by 100 and we will get 70%. So we can say that the model is saying that I can predict sick people with 70% of the time. Let's see this data. Here we have total let's first discuss one thing that is called class imbalance. So class imbalance means that, for example, if you are going to build a classifier that is going to predict about if whether a patient has a cancer or not, or whether a person has a brain tumor or not, or whether a transaction is fraudulent or not. So, in these cases, when we deploy our model to a production environment, then there will be out of 100 or out of 1,000, there will be one or two or 10 people that have cancer or that have brain tumor or the transactions are fraudulent. So, this is called class imbalance. So, one class has a large number of instances and one class has a very less number of instances. We are talking about the prediction on the unseen data. So if we have the same thing we have here right now, we have a positive class that we are actually interested in to predict. For example, we are interested to predict the sick people or people with have cancer or brain tumor or whatever. So there are actually 40 positive classes in our data, and we have 960 negative classes in our data. We are talking about testing data on which we are going to evaluate our model. So let's see what the model predicts. So if we see that there are 30 true positives, so 30 people were sick, and the model also predicted them as sick. 930 people were not sick, and the model also predicted them as not sick. That's correct results. Now coming to error. So 30 people were actually not sick and the model predicted them as sick. So they had no cancer, they had no brain tumor, and the model predicted them as not healthy. And there are 10 instances that had actually the disease or actually the cancer, and the model predicted them as healthy or as negative class. So if we calculate the accuracy of this model, the accuracy would be 930 plus 30 divided by 1000. We have total 1000 records. So our model is saying that it can predict the sick people with 96% of the time. Or we can say that it has 96% accuracy, which is a very good accuracy. If we only talk about the accuracy of the model, the accuracy is very good. But where is the problem? Let's find out where is the problem. So let's understand this false positive and false negative with respect to this example. So false positives are those healthy people that were incorrectly predicted as sick by the model, and uh, the false negatives are thus sick people that were actually sick, but the model has predicted them as not sick. So now we will decide. We are interested in finding those people that has the disease, or we are interested in finding those people that has no disease. So obviously we are interested in finding the patients with cancer or brain tumor or whatever disease they have. So we are interested in finding or detecting the disease in the patients. So, if a patient has a disease and the model classifies them as healthy, so that's the problem. That's the big problem for us. Uh, the second one is also a problem if a patient has no disease and the model predict is as particular cancer or whatever the disease it has or it predicts as not sick. That's also a problem, but that's not the huge problem. The huge problem is that if a model predicts someone who has cancer, who has a dangerous disease, and it predicts him or her as healthy. So here comes some more evaluation matrices. We have precision and recall. So let's first understand recall. It is calculated as the number of correct positive predictions divided by the total number of positives. It is also known as sensitivity. It ranges between 0 and 1. If the value is near 0, we will say that the model is performing good or we have a good recall. So recall tell us how many of the actual positive cases were able to predict correctly with our model. So if we talk about our model, true positives were 30 and true positive plus false negatives. So they were uh, 30 plus 10, 40. So 30 by 40 equals to 0.75. So we are talking about the recall. So out of 40, the model correctly detected the disease in 30. So 75% of the positives were successfully predicted by our model. But there is a problem. The problem is that we are actually designing a model that should classify or detect the disease with a greater accuracy. We saw that the accuracy was 96%. Accuracy was good. But if we only look at the class that we are interested in, that is positive class, and we see that the recall is 0.75. Now let's come to another evaluation matrix, that is precision. So precision is calculated as the number of correct positive predictions divided by the total number of positive predictions. It is also known as positive predictive rate. So its value is again between 0 and 1. And precision tells us how many of the correctly predicted classes actually turned out to be positive. So here in precision, we are interested in the predictions. So the predictions by the model, that the model classified some as positive or some as negative. So we are interested in positive class. So the patients that were predicted by the model as positive, so how many of the predictions were actually correct? So we are interested in this. So if we see that there were 30 true positives, so 30 divided by 30 true positive plus false positive, we have 60. So here we can see that only 50% of the correctly predicted cases turn out to be positive cases. So here we can see two problems exist. The first problem is that the model is unable to classify all of the patients as which has the disease as disease. So the model was able to only detect 75% of the patients with the disease. And now we can see that in precision, the the patients that were diagnosed as a positive class or as disease class, out of which 30% has had no disease. So 50% of the correctly predicted cases were turned out to be actually positive. So it will actually determine whether our model is reliable or not. So if we only talk about accuracy, accuracy was very good, 96%. But if we talk about the precision and recall, we can see that there is a huge problem with our model in predicting the positive classes, and the reason is that we have class imbalance issue.